Welcome to this session number 8 as part of the training program on Introduction to Python Programming and its applications in water resources sector. In the last session, that is session number 7, we have started working with Pandas, which is a third-party Python package meant for tabular data manipulation, analysis, and visualization. We have seen how to create Pandas data structures, namely Pandas data frame and Pandas series from scratch. We have seen how to read data from a CSV file into a Pandas data frame. And we have also seen how to write data from the tabular data from Pandas data frame into an Excel file. Today we will continue to work with Pandas. So like every time we will start with launching the Jupyter notebook. I will use Anaconda Navigator, graphical user interface. You type from the start menu Anaconda Navigator and then select the navigator shortcut, and when it is initialized you select the current environment, activate the environment python-wrm. Even though the Jupyter notebook as well as Pandas package will be accessible even from the base environment, make it a practice from now on to work in the environment created for this training program, that is python-wrm, and you launch your Jupyter notebook application. So it opens a new window in the web browser. Pointing to the home directory, I will go to the folder which I am working in, Python WRM, and the subfolder notebooks. Here I will create a new Jupyter notebook and I will rename and save it. Let us also have a look at the data which we will be working upon. I have collected few data files. One data file is gaze and discharge data, which we have been using. We have used it in the last session and even the previous session. It is a CSV file containing daily discharge data, gaze and discharge data of a hydrological observation site maintained by CWC, and the data spans over 11 years. And I have also collected some data, rainfall data, which is available online on indiawaterportal.org. There is a data set on monthly rainfall data district wise from 2004 to 2010, which is in XLS format, which is Microsoft Excel 97 2003 worksheet. The first sheet, it has general information, and from second sheet onwards, monthly rainfall data of each district from 2004 to 2010 is given, along with annual total. Where data is not available, it is given as NA. And then there is one file which I have taken data from the National Register of Large Dam, which is a periodical publication published by Central Water Commission, and I have collected copied and collected a text and have prepared a text file, CSV file, of all the large dams as per the definition of NRLD. Large dams uh, located within the state of Maharashtra. And then there is one more file which is XLX Microsoft Excel worksheet XLSX file extension file, which is which gives daily water level, reservoir level, and capacity, live storage capacity of a dam, Mulshi Dam. We have data spanning over 2007 June, 1st June, that is the beginning of the water year 2007. I think some 10 years data may be there. Anyway, it shouldn't matter. So these are the sample data files which we will be using, and I will also be providing these data files to you just for working with these data, for working on the pandas. We will use these data files. So it is always suggested to save all your data files in a separate folder named data inside the Python WRM folder along with your notebooks folder. So let us start writing our script. So we have to, as a first step, we have to import all the modules which will be useful. Now for file path handling, we will be needing pathlib, and we may also be needing OS, and then our workhorse, that is pandas, we will import it as PD as per the convention followed world over. Import pandas as PD, and I will run this cell. So pandas with all its functions, it will take some time to import. Then I will create a file path. To start with, we will see how to filter and update data in a pandas data frame. Let us try to read data from any data file and create a pandas data frame. I will start with I'll start creating the file path underscore gas discharge data. Let us create file paths for all the files so that we can call the file anytime we need in this notebook. So this all these files are in the folder data, which is inside Python WRM, which is inside home directory. Pathlib, inside pathlib module path class, we have a function home which points to the home directory, and then I am using / operator. The name of the folder is Python WRM, and then / the name of the subfolder data. Be careful with lower and uppercase letters, and then the name of the file, the CSV file, .csv. Similarly, let us create file path for a rainfall data. Just take care that there are no spaces inside the file names. And we have seen that this is an XLS format file. And so for reading this file, you may face difficulty in reading this file, which is in XLS format. In the last session, in the first session, we have seen um, for writing a file into XLSX, we have installed one package, um, we have installed one package called OpenPyXL in the Anaconda Navigator, and then imported it. Similarly, for working with XLS file, with Excel files with .xls, it may throw an error. So you can you can go to the environments and select the environment python-wrm, and I have already done installation. You can search for XLRD. You can search for XLRD by selecting all packages, and you select because I have already installed it, it is showing it in installed packages. You can select XLRD, which is a library for extracting data from Microsoft Excel spreadsheet files. You can select it and you can click apply here option and give time for installation of this package inside your environment python-wrm. Then you can also provide file paths to the remaining files, which is dam register, registry of large dams in Maharashtra, dams data, which is in CSV format. And file path to reservoir data. The name of the file dot extension, which is XLSX file format. So I have created 4 file paths and I will run this. So we can access any data at any time. Let us create a Pandas data frame by reading from CSV. So we have already imported Pandas, and then you can you know the function pd.read underscore CSV in case of CSV files, otherwise Excel files. You have to select read underscore Excel. At any point of time, you can make use of help option, which is available. And also one more utility is you can type tab after period to have a look at all the functions which are available with PD for auto completion of your code to avoid mistakes, syntax mistakes. So I will read CSV. I will provide the file path f file path underscore gd underscore data. Let us name this data frame underscore gd equals to, and let us run this cell. So a data frame has been created. You can have a look at the data frame. So you have this file of gauge discharge data from 1st January 2005 to 31st December 2015, 11 years, 4017 rows and 5 columns. We have explained this data set earlier. You can see that there are some nan values, not a number values, where the data is missing. How to deal with missing data, we will also will have a look today. Now coming to the topic, that is how to select, how to filter the data, how to select a subset of any data frame. There are two. There is in the easiest way is if you want to select any column, you can select the name of the column. So before going to that, let us rename the names of the column to So if you want to rename the names of the column, you can select the data frame, which is df underscore gd gauge discharge. Then you can type tab to see the functions. There will be a function or method in the name rename. You can have a look at help and how it operates. I'm directly using the function. So you have to you can rename the columns of a data frame by passing the columns argument, and by passing a dictionary of old name and new name pairs to the columns parameter. So the old name, as you can see, I want to change this. I want to remove the spaces. I want to these two names I will change. Say the old name is data type colon, and the new name is data type, just to show how the change take place. You can also give another, you can also change this name of gauge. So I will remove the old name colon new name gauge in meters. Okay. Let us execute this cell and see how the name of your two columns, they have been changed. Similarly, you can change other names as per the requirement, column names. Now, how to select suppose if I want to select column some column of a data frame, that can be done as you can visualize a data frame. When we defined it from scratch, it we defined it as a dictionary of series Pandas series in the last class, in the last session. So to access, in the case of dictionary, to access any value, we will pass on the key to the square brackets. Similarly, here also, to the data frame, which is df underscore gd, gauge discharge, you can pass the name of the column in square brackets. Say gauge in meter, and let us execute it. Key error. GAUG. Okay, actually what has happened is, in the previous cell we have assigned this data frame, and we have defined the data frame. It is after execution, these values along with the column names are stored, and when we have renamed the column names, it has done in situ, without changing, without making any change to the original data frame. So you can write, you can reassign to df underscore gd the data frame, and execute this cell, run this cell again by pressing shift and enter. And you can select the column now. And you can execute it. So when I am passing on the name of a column within square brackets, the data frame square brackets name of the column, it is printing the column along with the indexes, that is starting from 0 to 4016. The column is getting printed, and if you check the type of this, it is actually a series, Pandas series, as expected, because every column in a data frame is a Pandas series. So selecting any column in this way will result in a Pandas series. Now we have this by default indices are integers starting from 0. However, you can have your custom indices. Say we assign it to a variable series PD series 1. Let us create a series by the built-in function pd.series. pd series 2 is pd.series panda series. We will pass a list, simple list 1 2 3 4, which will create a panda series. You can also print it. So a panda series has been created. We haven't passed any name label. It has taken the indices. By default it takes 0 to 2 integer indices. However, you can customize the indices by passing an additional parameter index, a list of indices, say A, B, C, a list of strings A, B, C, D. Now let us print PD series, make it PD series 3. Let us print it. So a panda series has been created with the indices A, B, C, D and then the values. At any point of time you can reset the indices with the function pd series 3 is equal to pd series dot, you press tab to have select the function, which is reset index function. PD series 3, which is a panda series. Then the functions available with panda series, you press tab. There will be a function reset index, and there is a parameter drop to which you can pass on the value true and then execute it. What it does is it resets the any customized indices to the default indices by giving the value true to this parameter. Let us execute and see. So again the customized indices are dropped and then you got back the default indices. So that is about customized indices and resetting of indices. Coming back to what we were working on, the pandas data frame, the selection of columns which we have seen, it generates from any data frame. If we pass the name of the column within square brackets, it will generate a panda series and it will give the values of that particular column. Just as we have selected a single column, we can select multiple columns from pandas data frame. Our data frame is df underscore gd. So let us pass a list of whenever you are selecting more than one column, you have to pass it as a list of columns. So there will be double square brackets, nested square brackets. You can pass gauge in meters, the name of the column header, and then comma. The second column I will select. Copy pasting is better to avoid any typing mistakes. And our data frame is df underscore gd. After running, I have selected two columns. We are not making any selection of the rows, so all existing data within the data frame pertaining to the columns is getting printed, all the row information. So you can check the type of this. You had seen that single column will generate a Pandas series, and we expect this type should be a data frame, as there is more than one column, as it is a data frame, pandas.core.frame.data frame. So subsetting of a bigger data frame by selection of columns will generate another data frame. If you are selecting only single column, it generates a Pandas series, which is also a Pandas data frame, but of having only single column. Now in case if you want to select specific rows or columns from a data frame, till now we are selecting the full column and the whatever data is there, it is being selected. Now we want to be selective about we want to select specific rows or columns from a data frame. That can be done by using two operators, .loc operator and .iloc operator. Now you have to know one thing about uh, axis in any data frame, which is two-dimensional data structure. There are two axes. Axis 0 is along the direction of the columns across the rows, whereas axis 1 is along the direction of the rows across the columns. You please remember this. Then we are talking about selection of specific rows and columns from a data frame. Using .loc operator. Now this .loc operator goes along with axis labels. Axis labels as in here the column label and row labels. Column labels are column headers, which we have defined, or which has been selected when we are reading the file. The first row uh, the contents are selected as column headers or column labels. Then row labels, unless you are defining, like we have tried to define the row label by passing the indices. We had already seen this. By passing indices, you can have these are the row labels. Otherwise, by default, it takes integers starting from 0. So row labels here are 0 to 4016, whereas column labels are all the column headers. So .loc operator goes along with axis labels. The other operator .iloc, which I stands for integer index or integer index, it goes along with integer indices, which are same as row labels in this case, but it will be similar to the indexing which we have seen in case of default inbuilt data structures like lists are in the case of string indexing. When we were slicing the second the start index and end index we were passing, the end index is exclusive. So that type of indexing will go integer indexing will go with .iloc operator, whereas with .loc operator the row labels and column labels go along with this operator. At the cost of repetition, I am saying the same thing again and again, so that there should not be any confusion between .loc and .iloc operators. So let us select a particular row. I will try to select from our original data frame the first row, the data pertaining to 1st January 2005. So it is df underscore gd. If you are passing columns, we are passing within square brackets. Now you want to specify the rows and columns. That can be done by putting dot loc operator before the square brackets, dot loc, and you can specify the rows separated by columns, commas, rows, comma, columns. You can pass indices. You have to pass the row labels and column labels, or you can also do the slicing thing, or you can pass even the list of the rows or list of the column labels. So here I want to only pass the row 0. I want to select the values in the first row of our data frame. So as you can see in the first row, the data pertaining to 1st January 2005, 2.99 is the gauge and the discharge is 54.473. So here you can see the day, then the data type and the gauge value and the discharge. These are the this is the data pertaining to first row. Similarly, you can select any row and you can see that what has been generated is a Pandas series. So let us select multiple rows with dot loc operators, square brackets. Say I select row 0 to row 2. So you are having the first 0 to 2. Here 2 is inclusive. So why I was making the distinction between dot loc and dot iloc is this is not the slicing which we have seen in case of lists and strings, etc. It was about integer indexing, which will go along with dot iloc operator, whereas dot loc it is inclusive. So you will you have the data first first 3 rows 0 1 2. These are the row labels. We are passing the row labels. We are not passing the indices here. We are passing the labels. So 0 1 2, the data is printed. If you want to be selective about even columns, let us check this type. So it is a data frame. So whenever there is multiple columns, it will be a data frame. Any subset of a data frame will be a data frame. Now let us select even columns, df underscore gd dot loc operator and the square brackets. You want to have first 2 rows, then you want to be also select columns. You put a comma and you select the columns. You have to provide the column labels. Say I will select gauge meter to discharge qmax. These are column labels, and let us try to print it. I think we have to pass it in. These are strings. Yeah. So here what we are selecting data of first 0 1 2 row labels and columns from gauge to discharge, which is inclusive. The slicing is inclusive, unlike in case of indexing, integer indexing. So this way you can select specific rows and columns using dot lock operator. So there are other things, like if you are not passing any value of row and then passing a single column, it will print all values of the rows, just as in case of slicing, in list slicing, and it will print all values of gauge of all rows. So all rows 0 to 4016 and gauge values. If you are curious about what is this type, it should be series because you have single column. You can check more about selection, colon, comma, you will print all rows. Suppose you want to print everything from data type. You can say data type and then colon. Here, excluding the day, you want to print from here, and you are not specifying the end column, so it will print up till the end. Let us see. Yeah. And again, this will be a data frame. Similarly, you can df underscore gd dot log. You specify the rows. You don't specify the starting row and specify the first. You want the data for first 50 rows of columns day, data type, gauge and discharge, excluding observed or computed. You can do that up to discharge qmax. So you are specifying the end column and end row without specifying the starting row and starting column. So it will generate all the data from 0 to 50, inclusive of 50 row label, and from data type up to discharge, excluding the observed or computed column. So you have the data of first 50 rows of row labels 0 to 50, and day, data type, gauge and discharge. And so that is about using dot log operator. We will use dot log operator for even filtering of data based on a conditional, which we will see. Now let us look at how to select specific rows and columns using dot ilog operator. So dot ilog, as I was saying, it it will consider index integer indexing. Our data frame df underscore gd dot ilog, and within square brackets, let us say you want to have first let's say 0 to 4 rows, and you can even give the indices of columns here, integer indices of columns 0 to 3. So as we know, slicing, in whenever you are using integer indexing, it will be exclusive of 4. Therefore you will have the data pertaining to rows 0, 1, 2, 3, and data pertaining to the columns 0, 1 and 2, but not 3. So the original frame, the original data frame 0, 1, 2, 0 index is column day, data type, and mean gauge. These three will be printed. So let us check. Yeah. So for 0 to 4, exclusive of 4, first 0 to 0, 1, 2, 3 rows, and columns 0, 1, 2 columns exclusive of 3 is getting printed. So this way you can use .ilog. You can also pass on df underscore gd dot ilog, pass on the list, say list of rows, list of row indices. Suppose you want to even include 4, 0, 1, 2, 3, 4, and then comma, columns, you don't specify anything. Let us see what it does. Yeah. So you could have done this using .lock and then slicing 0 to 4, which will print inclusive of 4, whereas with slicing with .iloc, the end index will be excluded. However, if you are passing a list of indices, it will include data pertaining to all indices. Suppose you want to have data of specific rows, say you have data of 1st January 2005. Let us print the data of 1st January 2005 and then 1st January 2006, and the corresponding row should be 365. Let us see. Yeah. So you can, in this way, you can select the rows. You can pass on the list of row indices, and you can print the value on on the particular day of a year or particular day of a month. Every month you can print. Let us check whether this is also applicable with .lock operator. Yes, the same is we can do with .lock operator. Suppose you want to print the last row. of your data frame. You can simply use .ilog. As in the case of negative indexing, you can give the index -1. So the last data is in our data frame is from 31st December 2015, and these are the values as you can see from the original data frame. So that is about selection of specific rows or columns using .loc or .ilboc operators. There is one more operator .at, which gives value at any specific row and column. Say 0, 4. It is giving key error. Okay. You cannot pass the index as in case of .ilboc. You have to pass the name of the column. So particular value at a particular row 0 and the column gauge meter, it is 2.99. So you can check in the original data frame the value at row 0 is 2.99. Let us print the value at row 4, which is or 4012, which is actually, it is the data type is HHS, that is gauge with respect to the mean sea level. We'll print that instead of 4012. So as you can see, the value is 258.04 with respect to mean sea level. So that is the utility of .at operator. And there is one more shortcut of, like, if you want to drop some columns, you can df_gd dot drop. So in the original data frame, as you can see, what is important data for you for data analysis, the data type you can remove, you can drop, and observed or computed you can remove. You can remove these two columns and retain day, mean gauge, and discharge. You can do that using this function dot drop. You can pass on the list of columns that you want to drop. One is data type and another is and you have also have to specify the axis. So along you want to drop some columns along this axis, which is axis 1. As we have said, axis 0 is in this direction, axis 1 is in this direction. So you can specify axis is equal to 1. So you can see you have dropped select two columns along the axis 1. You have dropped the data type and the observed or computed columns. Similarly, you can drop specified rows. Let us also have a look whether it works. So you want to drop rows. Say I want to drop the row number 4016 along the axis 0. Yeah, 4016 row has been dropped. We can also select rows based on conditional expression. We will see that. So we have this gauge and discharge data of a site where we have discharge data. Let us have a look at the discharge data, the original data. As you can see, the discharge is varying around during winter months, that is January and December, it is around 55. Let us identify 100 QMX as the mark, and let us say discharge above 100 QMX. Discharge above 100 QMX. We have defined a new variable and we are assigning our data frame before doing that. Let us get our data frame and see the column name is discharge QMX. Which all rows have discharge greater than 100. So in the data frame, which all rows have discharge greater than 100. Let us see what it df underscore, sorry. Yeah, now what it is doing is it is checking the discharge value for each row, and it is returning if it is less than 100 QMX, it is returning false, or if it is greater than 100 QMX, it is returning true. You are unable to see all the rows from 0 to 4016. So the data type here is Boolean. We have created one if I am not wrong, we have created one series of Boolean type with entries as true or false. Now with this conditional expression. Now to make better use of this, if I assign it. So it is a Panda series of Boolean values with same number of rows as original data frame. Now, sorry, if I pass this Boolean series into our data frame, this will print only those rows with the value true selected. So you will see only those rows with discharge greater than 100. That is, those rows here which are returning true only will be selected. This will generate a series with a series of Boolean type, and when it is passed into our original data frame, it will return only those rows which have Boolean value true. So as you can see, you can identify those rows where the discharge is greater than 100. There are around 1927 such rows, whereas the original data frame we had 4016 no no 4017 rows. So you have the dates where the discharge has exceeded 100. Similarly, you can check on dates where the discharge has exceeded 200 and so on. Now, if you want to if you want to save it as a different as a data frame, you can do that. You can say discharge above 100 qmax, and you can assign this to the variable defined, and you can also reset these values of row labels by using the function dis, uh, discharge above 100 qmax. This is a data frame now, a subset of the original data frame based on conditional expression. Press the tab, you will see the functions which are there. You will see a function of reset index which can be used to reset in indices by passing parameter argument true to the parameter drop. So it will drop all the original indices, and it will create new indices from 0 to 1926. That is, there were 1927 rows, and you have those dates where the discharge has exceeded 100 qmax. So that in that way we can select rows based on conditional expressions. We can have multiple conditional statements, combination of multiple conditional statements um, by and operator combining the conditional statements. Now let us see it in case of another data frame, as we have said that we have created file paths to many. These are all the data which we have. Till now we were working with gauge discharge data. Let us open this Maharashtra dams NRLD, the register of large dams from the state of NRLD document is prepared by Central Water Commission, and we have selected only those large dams from NRLD which are located in the state of Maharashtra, and we have already created the file path, and it is also a CSV. So let us create a new data frame using this file path, and so I will create a data frame, naming it data frame underscore dams is equal to pd dot read underscore csv fp underscore dams underscore data. I am passing this file path. Let me see how my data frame looks like. So the data frame, actually our CSV file, the delimiter is not comma. As you can see by opening the file, it is a tab separated value file. So we have to pass an parameter sep which is equal to tab. Tab is written with backslash t, special character backslash and t. So let us run it. Let us run it here in one more line. And let us print our new data frame. Yes, now it is looking better. So our new data frame has 2887 rows. That means there are 2387 large dams in the state of Maharashtra. And the information is contained about these dams in 19 columns, starting from serial number, then some ID for the dam, then name of the dam, latitude and longitude, the location we have, year of completion of the dam, river basin, and the river, nearest city to the dam, which seismic zone it is lying in, and then height above the lowest foundation level, dam length, volume content of the dam, gross storage capacity of the reservoir, reservoir area, effective storage capacity of the reservoir, purpose. Now there are many nan values because the data is not full. Then the purpose, whether it is irrigation or hydropower, then the design spillway capacity. So we have lot many values. So let us apply some multiple conditional statements here and select rows. Now let us see the height of the dam above the foundation level. I think it is in meters. So let us select those dams which are let us first rename our column with simple height, and then let us also select any other useful column header. Gross storage capacity, it must be in cubic, sorry, not cubic, meter cube. 10 power 9 meter cube means how many? 10 power 6 is a million cubic meter. 10 power 9 means it is it BCM? Yes, 10 power 9 is, so this data is in BCM. It is in a meter cube. The gross storage capacity at the time of construction of the completion of the dam, the gross storage capacity was that. Even now the gross storage will be the same, but effective storage capacity may have come down because of some siltation. However, let us select these two parameters: height above the lowest foundation level, that is length, the height wise dams, as well as storage wise big dams. Let us take these two parameters. Let us rewrite the names of these two columns as we have done earlier using the function rename. we will do it in the case of this. So our data frame is df underscore dams, rename columns. Which all columns we want to change? Number one, this column, to make it manageable. Otherwise, every time we have to write this long string, and I will rename it as simple height in bracket meter. And then second parameter, which I want to change the gross storage capacity. Similarly, you can take dam length, it is also in meters. Then effective storage capacity, that is live storage capacity. Spillway capacity, I guess it is in Qmex. So the second column which I want to change is gross storage capacity. I will simply for simplicity purpose capacity, and I write it as meter cube. So I have run the cell. Let us print how our data frame looks like now. So this columns height in meters and capacity in meter cube, it has changed. Now let us identify very big dams which are both high and large capacity, large dams having high height above let us take 100 meters, and then capacity, let us take 2 into 10 power 9, that is about 2 BCM. So I will call them very large. These are all large dams as per the definition of NRLD. I will for our sake I will define a new variable, very large dams. Then first of all, let us check with the conditions. Now df underscore dams, and then you have to pass the condition in this manner. Df underscore dams such that ds underscore no, first you start with this. Df dams height greater than 100. Let us check this too. So one condition, and another condition is capacity greater than 2.0. You have to write in the same fashion, exponential notation. e power 9. Let us also check it. Yes. So let us have two categories. Say big dams. My own definition of dams with capacity greater than 2 BCM, gross storage capacity greater than 2 BCM, and height greater than 100 meters. You can combine both these conditions using AND operator. You want both the conditions to be satisfied. So it is up to you. You can have AND or operator can also be applied. Here AND operator is written as ampersand symbol. Then I am putting the condition in the parenthesis. Similarly, this condition. So let us run this. Again, this gives a Boolean data type, what you call series. If I assign it to big dams, a variable, this condition I pass on to the data frame. Inside the data frame, df underscore dams, and in square brackets the combination of both these conditions. It should return the corresponding values of the data frame, rows of the data frame which have turned true. At least you can see at least the first row is true. It is a big dam, so at least you should see the row 0 when you run this. There is at least one value, one row. So let us print big dams, and there is actually only one dam at row 0, which is of height greater than 100 and capacity greater than 2 into 10 power 9. Let us which is Koina dam of height 103.02 and capacity 2.9 BCM, 2.98 BCM. You can relax it. Say, I will say these are very big dams. You run it again. Then I will give another criteria. I will big dams where the height I will say 75 meters and capacity say 1 BCM. Then I will print big dams. It is again giving only one. I hope the previous cell is not overwritten, so I think we have to give some more concession to the dam height, like let us say it is 50 meters only. I will run it. So as we have at least there are 3 entries: Koina, Ujjani, that is Bhima, then Totlado. So you have this information, their locations, year of completion, river basin, Koina basin, and Ujjani is on Bhima. Totlado is on Pench river of Godavari basin, where the height, as you can see, is greater than 50 meters, and then volume capacity is also greater than 1 BCM. So in this way you can select rows and columns from a very big data set. You can give as many conditions as you can, and you can combine them using AND or operator. Just as AND operator, you can have OR operator. Let us say you use OR operator. OR operator is this symbol. So you call it either of the condition somewhat big dams, and you print it. This should have more entries. Let us check. But 100 meters is actually is a big height. However, capacity, if it is greater than 2 BCM, that will also, because either of the conditions should be fulfilled. So there are only 5 entries, 0 of rows 0, 1, 2, 5, 5, 6, 1, 2, 2, 6, which are Koina, Jayakwadi, Ujjani, Middle Vaitanna. Then this is Adivali, which doesn't, which says it says it is of height 125.52, but capacity is very low. This may be a wrong entry. While preparation of CSV file, there may have been an error. It may be, maybe it is just 25.52 meters. So you can, that way you can even identify, and you can also see that this capacity, everything are proportionately, the volume content, everything are proportionately low. It cannot be 125.52. I am not sure. So in this way, someone who knows the local information, so someone from WRD Maharashtra, Government of Maharashtra, they can say it is a wrong entry. So they can do the rectification. So by using these conditional statements along with information at hand, you can filter the data. You can do the selection. So if you are able to filter the data using these dot lock and dot ilock operators, select specific rows or columns using these operators, and also select rows based on conditional expression or multiple conditional expression in combination, you will be able to identify the wrong data, the data points which are out of range or which have been made wrongly, and you can update such data points um, once you are aware of the local information. Let us see one example. Like we have our data gauge discharge data frame, where we have some values of gauge with respect to the mean sea level, where the data type is HHS. In such cases, we don't have the discharge values populated. The not a number value is there. Not a number value nan entry is there. So if we can identify all those data uh, entries where the data type is HHS and the gauge is with respect to the mean sea level, we can update the values using the information about the benchmark mean sea level. Then we can subtract it from this value to get the absolute gauge value, and applying the rating curve formula, we can get the corresponding discharge, and then you can update even this column as computed discharge. So let us see whether you can identify how many values are there with how many such rows are there in this data frame. df underscore gd, where df underscore gd gauge in meter is greater than, I think, 200 meters. So let us assign it to a variable HHS, gauge discharge data underscore HHS. This will be a data frame, and let us try to get the size of this using the attribute shape. So there are 41 entries. There are 41 entries, rows, where the data mean gauge data is with respect to the mean sea level. So you can apply the filter. We can update these values, and accordingly you can apply the formula and calculate the discharge and change this to C, that the computed value. In that way you can even update your data set. Now let us have a look at some more methods which are available for data manipulation and getting descriptive statistics and creating basic plots using pandas. You can sort the values of a data frame by selecting the any column. Let us take our data frame of dams. So you can sort by the values of height or length of the dam or volume or capacity. Say df underscore dams dot, using this method sort values by the name of the column label is, say, dam capacity. So this has been sorted on the basis I think it will be sorted in ascending order. Now whereas we want you can get it in descending order by overwriting the default parameter. Ascending is false. So capacity wise, within the state of Maharashtra, the gross capacity of the biggest dam is Ujjani, then Koina, then Jayakwadi. The values, then Isapur, Totlada. The value is 3.3 BCM. Similarly, you can do the sorting by height. So in this case, Yeah, we talk about it. This may be a wrong entry. Then the highest dam is actually Koina, 103.02. There is another dam, Vaitarna, which is more than 100 meters, middle Vaitarna. So in this way, you can sort the values. You can also get the values of mean, minimum, mean value, minimum value, maximum value, then even standard deviation, etc. From we have seen the describe method, the basic statistics of every column. You will get count, mean, standard deviation, minimum. 25% values are above these, and maximum 50% values, 75% values are above this. So some doesn't have any meaning, like serial number, it doesn't have any meaning of getting a mean. Latitude, it doesn't have any meaning of getting mean or median. Height, dam length, volume, spillway capacity, etc. You can have a look at maximum and minimum values. If it is rainfall data, you can have a look at mean value. If it is discharge data, you can have a look at mean value, etc. You can also make use of you can select any column with its label and then get the value, say max. So it is let me take capacity. We have seen Ujjani should be the should have the maximum value, which is around 3.3 BCM. So in that way you can do that. Now let us see our case discharge data frame. Now suppose if I want to have monthly mean values, say I want to have monthly mean discharge during the month of January 2005. I can do that with first I have to select the corresponding row with the labels 0 to 31, included 31, and then column you select the discharge in Qmax, and you calculate the mean monthly discharge, which is 41.675 Qmax. Similarly, for corresponding row labels of any month, and even for say monsoon period, how much is the mean discharge, etc. You can do many calculations. You can get descriptive statistics of the data frame. Now, after having a look at the basic statistics, let us have a look at the basic visualization, which is a key part of data exploration. Pandas comes with it methods for basic plot, the dot plot method, which is actually a method of matplotlib module, pyplot submodule, which we need not import it here, as Pandas comes along with its dependencies. So let us try to make a basic plot of discharge. We have the discharge data frame. We will change the index by setting the index to day by using set index method. I call it GD underscore GD1. DF underscore GD1 is DF underscore GD. You apply the method of set index. The name of the column is day. Column label is day. And you pass on the parameter value true to parameter drop, and then print df underscore gd1. So as you can see, the index has been replaced by day column, whereas remaining columns they are the same. Now df underscore gd1, I select the discharge qmex column and try to make use of plot method and see, yes, it is generating a plot with x-axis the dates, the day, and on y-axis the discharge. The maximum discharge, as you can see, it goes up to around 3800 qmex. And every year, as you can find these cycles of spikes coming during the monsoon, and then going down, and then again during the monsoon. When it is normal rainfall or excess rainfall years, we have peaks, the peak going above 3000 qmex, 3000 to 500 qmex. Whereas if there is a deficit rainfall, I think in during deficit years the peak of the discharge goes up to 2000 qmex. And there are some very dry years, I guess, then the discharge was very low, around 1000 qmec. So here it is a bit clumsy because on the x-axis we have 11 years data. There is one more functionality where you can pass data directly when you are reading the when you are reading the data from the CSV file or Excel file. Let us also have a look at it. I will call it df underscore gd2 is equal to pd dot read underscore CSV. We have the original CSV file of gauge discharge data, which has the file path defined here. Whenever you are doubt, you can have a look at help option and see what are the required. This is the file path which has to be which is a necessary parameter that has to be passed, and there are many other optional parameters. Among the optional parameters, there are optional parameters where you can assign index column directly. And in case if you have a look at the original data, the first column itself is a day, so that column index is 0. So index column we can pass it 0, and then you can set pass dates parameter to true. Then it will automatically pass dates. You will see the what we mean just in a while. So when it is passing dates, Pandas has a datetime object, datetime method defined in it. So you can see the dates are in the fashion year dash. It is able, Pandas is able to read the data, CSV data, and it has passed the dates, and it has printed it in the format year, then a day, and then month. So let us now try to plot the data which we have. df underscore gd2, we want to plot the discharge qmex dot plot method. Yeah, this is a much better plot than this. The same values. If you take subsets of x-axis, you will have a better visualization. So you can see that 2008 year was a very good year. Monsoon was, you can even verify, even though we don't know the location of this site, we can get a rough idea that 2008, 2013 were good years, whereas 2012 was a very 2012, if it starts from here, monsoon should be somewhere. 2012 was a dry year. 2013 was a very good year. Here it is 2006, 2007. So anyway, this is how we plot we in pandas. We can also have a scattered plot by passing x and y parameters inside this function. Let us say I pass x gauge. Where is our df underscore gd? The gauge and y equal to discharge qmax. Yeah, you can have a plot of gauge versus discharge. There are some this is an outlier. However, you can see you can you can fit a curve, uh, and then you can read discharge from by measuring the gauge absolute gauge value. If you fit a curve and get the equation of the curve. So we have another data file with us, the reservoir storage file, which is the .xlx file. Where we have the date in the column number 0, 1, 2, column index is 3. Here actually we have the code in column, first column, second column the name of the dam or reservoir, the name of the state, third column, fourth column date, fifth column level, water level, and sixth column capacity of the reservoir. I think it is in BCM. So day is at index 0, 1, 2, 3. Now let us read this data into a data frame in the same way as we have done, and set passing dates true. Let us pass the dates. So I define the data frame reservoir. We have already defined the file path at the beginning, fp underscore reservoir underscore data. So pd dot read excel, you pass the file path, then uh, the parameter index call is equal to 3, and then pass dates is equal to true. Let us look at our data frame. It is taking time to read the data. I think the data is spread over many years. Meanwhile, we can talk about other functionalities in Pandas. Uh, just as we have created a data frame from a dictionary of series by collection of series, similarly we can create a data frame from lists. Um, if we have a text file, sorry, if you have a text file with which is the source of your data, we can read the text file. Even CSV is a text file, but if you have a txt file, we can, and we have a series of the data, you can create lists out of those series, and then you can create panda series out of those lists, long list of numbers, and then you can create a data frame. That is also possible. We are not doing that. So our data frame has been created, df underscore reservoir. The dates has they have been passed as it is. You can see in the fashion year, month, and then day. Now let us have a plot. There are 3653 rows. I think it is a data of 10 years data, daily data. So you have df underscore reservoir. You select either level or capacity. Level in square brackets, and then dot plot. So you can see a clear plot of how reservoir filling and depletion take place every year, starting from our data is starting from 1st of June 2007, that is starting of the water year, and it is ending on 31st May 2017, the end of the that particular water year, another water year. So every water year the reservoir fills up, it goes up to its maximum, almost maximum capacity, somewhere around this maximum water level. On y-axis we have water level. So so in a cyclical manner it goes down and reaches the peak, and around September or October, after the monsoon, it reaches the peak, and then the depletion again take place. So in that way we can have some basic plots and basic visualization for data exploration.
Let us move forward. We will see how we can derive new columns from existing columns of a data frame. We will make use of the remaining data file, which is IMD district-wise rainfall data, which collected, which is made available uh, in a portal, India Water portal. So the data is from 2004 to 2010, and each state data pertaining to each state is in a separate worksheet of this XLS format file. XLS Microsoft Excel 97 2003 worksheet. So for working with this file, um, there may be you may see an error that one module is missing, XLRD module is missing. So what I have done is I have installed the XLRD, that is a library for developers to extract data from Microsoft Excel spreadsheet files, in using Anaconda Navigator in my Python dash WRM environment. So you can also do the same thing by searching for the XLRD in all packages and then selecting and then applying, and wait for its installation. So here, the first sheet is general sheet without information. Then the next sheet onwards there is rainfall data. However, there are many missing values or no values which are represented by n dot a in this. Now, whenever you are importing any data into a data frame, any data from a CSV file or Excel file with empty cells, that is missing values, automatically the pandas data frame converts those empty cells into nan cells, not a number, NaN, and such cells are not considered during any operation or calculation with the columns of the data frame. However, here we don't have empty cells, but we have a specific um, uh, specific way of mentioning that data is not available. So better select the sheet without any NA value, or another option is you just delete these NA to make them empty cells. So I was saying that the missing data from, whenever you are reading data from CSV and XLS format, the missing values will be automatically taken care of. If there are empty cells, they will be converted into NaN cells and they will not be considered during calculations. So let us try to import the Excel file into the data frame. I will create a new data frame, a pandas data frame, df underscore rain, by reading the Excel file, passing the parameter that is the file path. Now file paths have already been defined in the beginning. Let us have a look. fp underscore rainfall underscore data. You paste it and have a look at the data frame, df underscore rain. So it has taken the first first sheet by default, which has a description of the data set. So to select any particular data worksheet, you have to pass the parameter sheet name, which by default is set to first sheet. You can override this parameter by passing the name of any state, say Karnataka. Then let us check our data frame. So the data frame has 189 rows. It has district-wise rainfall, monthly rainfall values for the years 2004 to 2010. And also there is a annual total column in the end. Now let us try to create one more column, monsoon rainfall, by adding the values in the columns, by adding the four monsoon month rainfall pertaining to four monsoon months. So df underscore rain, a new column. For creation of new column, you simply assign the summation of the values of four columns to a new column, calling it df rain within square brackets monsoon, that is equal to df rain June June, then July, August, then September. You run it and check your data frame df underscore rain. So there is one additional column has been created. Now there are 17 columns. One additional column of monsoon has been created and is appended. So this way you can create new columns using the derived from the existing columns. Let us group the data. We make use of, there is another function called group by, which will be very useful for summary statistics. Say you have our data frame is df underscore rain. You use this group by function, and I want to group the information as per the district. So I will pass district within quotations, and I want to have mean values. So what it will do is it will group all the remaining columns district wise, and it will calculate the mean of every column. So you may see that even it has calculated the mean of the year, which has no meaning. That is 2004 to 2010. The average is 2007, and it has also given made it a data type of float, which is absurd. Anyway, the remaining values from January to December, and then annual rainfall and monsoon, you have got the average annual rainfall, the mean rainfall, district wise mean rainfall. So this is very useful functionality. You may check in the Excel file. Meanwhile, you can also group it, the data by columns, mentioning the columns. Like I can select only two columns, annual annual total and then monsoon. So we have seen it in the beginning how to select columns from a data frame. If there are more than one column, we have to pass the list of columns within square brackets. So, so within square brackets, we are passing the list of columns. So this will be a data frame, which is a subset of the original data frame. Then we will group by district, and then we will print the mean values. It is giving a key error. Okay. Yeah, your input should also have district. So now you have annual rainfall and monsoon rainfall grouped district wise. Basically, you have brought these two columns here. You may just verify the values by going into Excel file and then calculating the having looking at the value of mean. Even otherwise, the values are very reasonable. The coastal districts have high rainfall, and much of the rainfall happens during the monsoon. And then interior districts which are drought prone, like Bidar, they have low rainfall. Let me just, anyway, that is not needed. You may do it, verification you may do on your own. Then we will there is one way of applying any method. So whenever you are doing creating a new column, we are whenever you are trying to calculate mean, you apply any method, it is being done element wise. So we can uh, apply any function, user defined function also, with a method called apply method. So we have this data frame df underscore gd1 with day as the index, which we have created earlier. We have the discharge in qmex. Now we will try to convert this discharge in qmex to discharge in qsex. For that, we will define a user defined function. Define qmex underscore to underscore qsex. You pass qmex parameter and then colon, then next line indented. Qsex is qmex into 35.315, and you return q6. So this is a user defined function. Now we will apply it to in our data frame column, which is discharge qmex dot apply, by simply passing the name of the function as a parameter to apply method, name of user defined function. And you save it in a new column. Discharge q6. It is equal to df underscore gd1 discharge qmax dot apply qmax to q6. Let us execute it and let us check the data frame. You can see that a new column has been added, and you can see that wherever there is nan value, it is not being considered for calculation. Nan is being written. Whatever gets operated on nan, it will return nan. However, if you take mean of all the values of discharge as well as gauge, let us take the mean and see df underscore gd1 we have done it even before also, but just to illustrate the point that nan values will not be considered for group for this computation. Mean it is yeah, it is in q6, so it is okay, it is fine. 7556.72 q6. So it will while doing the average, this will not be taken into account, so it will do the sum and take the average without considering this or any other nan value. So missing values are easy to manage in Pandas data frames if you are importing the data with empty cells. Otherwise, you have to make it you have to fill the missing these empty cells in as nan values. Nan is actually it comes from numpy, which is numpy element, numpy object, not a number. We will see numpy. We'll try to cover numpy also, basics of numpy in one session. So that is about creation of new columns and applying of function apply, which will be any user defined function will be applied to all to any column. And we have also seen grouping of our values. So we have covered most of the basics which are required for data manipulation. We have also seen data visualization, basic data plot, data analysis. Also we have to take it forward, making use of these methods. And in the user guide of Pandas there are many methods which you can make use of. There are other important topics like reshaping the layout of tables, then how to combine data from multiple tables, then pivoting, how to join tables using a common identifier, and how to handle time series data. Now handling time series data we have covered. Now there is a function called to underscore data time in Pandas, which when applied it interprets the strings and converts them into date time objects, which when you have any data like you can convert, say we while read but we have actually done it in a another way. When we have read these uh, yeah, when we read the CSV file, we have tried to assign we have instead of default accepting the default indices, integer indices, we pass data. We have given index column as the day column, and we have passed dates we by making it true. So this has converted what the Pandas has done is it has converted the column of day and into a date time into a date time objects. So, and then we have also plotted. So same thing uh, can be done by two underscore data time function in pandas, by assigning by applying it to any column. It will column of strings if it is in date format, if it is in some date format, year, month, and containing year, month, day, as well as time, hours, minutes, and seconds. So there is a date time objects in pandas which will be very useful. So it will interpret those strings and convert them into date time objects. So in a way we have already covered that by this function, by this reading of data from Excel and then using date as an index. So we may conclude this session. There are many more functionalities. There are many more functionalities there where you can manipulate the text data and do many sorts of things which is difficult to cover in everything in a session in during a training program like this. We will be providing the documentation of pandas which is available on the website of the pandas package. You may go through it, and also on the website of the pandas there is a tutorial of getting started which is very useful for beginners.
That brings us to the conclusion of this second part of the session on working with pandas. Thank you very much.